by the end of this presentation, you should be able to list the factors that affect solubility, determine if potassium chloride is an electrolyte, or distinguish between saturated, unsaturated, and supersaturated solutions. All these examples here are solutions. So don't think that just because it happens to be a liquid that it's not a solution. Steel is a solution of iron and carbon. Air is a solution of nitrogen and a bunch of other gases. Oops. Sorry. Alright, so a solution is a mixture of two or more substances in a single phase. So it doesn't matter what your state of matter is. It could be liquid, solid, gas. Two things make up a solution: the solute, which is the part of the solution that's being dissolved, and the solvent, which is the part of the solution that's doing the dissolving. The solvent is also the one that's more abundant. So you're going to have more of the solvent, and you'll have less solute. Solutions can be unsaturated, saturated, or supersaturated. If you have an unsaturated solution, that means you have less than the maximum amount of solute that can dissolve at a particular temperature, meaning that you could add more and it will still dissolve if you want to. Saturated contains a maximum quantity of solute that dissolves at that temperature. So it's like at equilibrium. It's at the perfect amount. Supersaturated contains more solute than is possible to be dissolved. So you have to force supersaturated solutions. You'd have to heat up your solution to make these. They're very unstable. Factors that affect the rate of solubility. Okay, this is important. These four factors affect how fast or slow it can dissolve, not its ability to dissolve. That's something different. We'll get to that. So surface area, large pieces dissolve slower than small pieces, right? If you break something up to dissolve, like an Alka-Seltzer or something, it's going to dissolve faster if you crunch it up and make it into smaller pieces. Temperature, if you add heat, it'll make the substance dissolve faster, and likewise, if you cool it down, it will dissolve slower. Stirring makes it dissolve faster, right? You put sugar in your sweet tea, you just give it a stir, it dissolves faster. Also, if you increase pressure, it will make it dissolve faster, but this is only for gases, okay? That's real important. If you increase pressure of a solid or a liquid, nothing's going to happen. Temperature and solubility. So solubility of solids and liquids increase with increasing temperature. Solubility of gases decreases with increasing temperature. So they're opposite. This is a solubility graph, and they always have lots of lines on here, lots of different compounds. On the left side is grams in water, so grams of your solute in grams of water, and on the x-axis is temperature. You only focus on one line at a time. So say I wanted to dissolve 20 grams of potassium nitrate at 30 degrees Celsius. So I'm only going to focus here on the line for potassium nitrate. I'm just going to ignore all the others. So if I'm dissolving 30 grams at 30 degrees Celsius, you see how my point is below the line? That means it's unsaturated. If I wanted to make it saturated, I'd have to add more solute. So at this particular temperature, about 45 grams of potassium nitrate will give me a saturated solution. So saturated is on the line. If I were to add any more and make it above the line, it would be supersaturated. So after 45 grams, any more is just going to fall and sink out to the bottom unless I force this to happen, like heat it up. If I heat it up, I can dissolve more, but it's very unstable. All right, pressure and solubility of gases. So pressure increases, then solubility increases. And if pressure decreases, then solubility decreases, right? Because the gas will fill its container. Like dissolves like. All right, so this is what I was talking about before. Temperature increase, stirring, that affects the rate, but the fact if it can dissolve or cannot dissolve depends on their intermolecular forces. So if a molecule is nonpolar, then it's going to be soluble in nonpolar solvents. If a molecule is polar, then it's going to be soluble in polar solvents, and ionic compounds are more soluble in polar solvents. So you'll have to remember what makes a molecule polar or nonpolar. Alright, compounds in aqueous solution. Remember we have the states of matter in our reactions, and there's that little AQ. All that means is it's dissolved in water. Your solvent is always water in an aqueous solution. So KMnO4, this is an ionic compound, so it will be soluble in water. And what happens is the polar part of the water molecule, this is my little water molecule, the lone pairs, this part's partially negative, these little parts are partially positive, and so the oxygen here is attracted to the positive charge of potassium, and so they surround them and they pull it apart, and that's called solvation. So how do we know ions are present in aqueous solutions? Well, they conduct electricity, and they're called electrolytes. So for example, hydrochloric acid, magnesium chloride, and sodium chloride, they're all strong electrolytes because they dissociate completely into ions. So all acids and ionic compounds are electrolytes. Compounds that don't conduct electricity are called non-electrolytes, like sugar, ethanol, ethylene glycol, because these are all non-polar. They don't break apart into ions. So there's no flow of electricity. Electrolytes in your body are important because they carry messages to and from your brain, and they maintain the correct cellular function. So if you've ever gotten muscle cramps, you know, your coach will tell you eat a banana, or I guess some girls drink pickle juice, which is gross, but it's because it contains those electrolytes. Like bananas have potassium, and potassium, that's what makes your heart beat. Passes over your cellular membrane, makes your heart beat. That sodium-potassium pump. Alright, if you can't answer the questions at the beginning of the video, then please watch the practice video. Or watch this one again.